Let us just continue with our next speaker, Jesus Alberto Jaimes-Arriaga, with his lecture, The Atom in Molecule Construct, a Case of Downward Causation in Quantum Chemistry.
Well, thank you for the presentation, Camilo. And well, I'm going to address the well-known problem of the reduction of chemistry to physics. And in this case, I make the case for the phenomenon of downward causation in quantum chemistry. Then the outline is as follows. I will start by the introduction, the problem, and state the aims of this work. Then I will introduce the main tenets and the mathematical structure of the quantum theory of atoms in molecules, emphasizing the role of the zero flux surface. And finally, I will give some reasons to interpret the role of the zero flux surface as a case of downward causation or a manifestation of the downward causation. Bien, the introduction. Well, in contemporary analytic philosophy, we can identify two different philosophies of nature in dispute. In one side, the Aristotelianism that is committed with an ontology of fundamental causal powers, necessary connections, the priority of wholes over parts, and well, Aristotelianism also tries to capture a broad body of knowledge that includes physics, chemistry, biology, and the rest of sciences. And also the Aristotelianism considers the manifest image of world as fundamental as the scientific image. And also considers take into account the top-down explanation. In the other side, Humanism is commonly described in terms of the Lewis-Humean mosaic of local matters of fact, and Humanism commits with contingent relations, the sufficiency of modern physics, and the priority of parts over wholes. And for Humanism, the scientific, defends the idea that the scientific image is superior to the manifest image, and also the bottom-up explanation is superior to the top-down explanation. Humanism crystallizes in the doctrine of microphysicalism, according to which microphysical parts of composite wholes are fundamental substances and are metaphysically prior to their wholes. And this claim is defended on the basis of the mereological supervenience. That is the idea that there is not a change in the properties of the whole without a change in the properties of the parts. And the Aristotelian counterpart of microphysicalism is the hylomorphism. That is the doctrine that defends the idea that the whole is prior to the parts. And this priority of the wholes is defended on the basis of the downward causation, particularly formal causation that is understood in terms of downward causation. And well, the idea of downward causation is not new in philosophy of chemistry. Robin Hendrick has largely worked in an approach in which chemical entities strongly emerge as stated by downward causation. And most recently, Robert Kuhns developed an Aristotelian alternative in which wholes and parts are in a relationship of mutual metaphysical determination. In this case, the top-down and the bottom-up explanation are balanced. Bien. Well, we defend a hylomorphic account based on the metaphysical priority of the whole over the parts in mereological relationships, but by postulating the causal form as top-down metaphysical determination, that is, a determination from the whole to the parts. Regarding the mereology of chemistry, the idea is to defend the priority of the molecular wholes over the atomic parts. And well, in the molecular domain operates the theory of molecular structure. Meanwhile, in the the level of the nuclei and electrons operates quantum mechanics. In the middle, we have quantum chemistry, that is the discipline in which the principles of quantum mechanics and the principles of molecular chemistry converge. And in this work, I am focusing in quantum chemical theory, that is the quantum theory of atoms in molecules. And this theory is interesting because it tries to offer a quantum foundation for the theory of molecular structure and the Dalton's atomic theory by appealing to the idea or to the notion of topological atom or the atom in molecule concept. Well, synthesizing this work aims to defend a hylomorphic approach based on the mathematical structure of QTAIM, and especially on the notion of zero flux surface proposed by this theory to define the concept of atom in molecule. Well, in the philosophy of science community, it is assumed the Nagelian reduction model. According to this model, a theory T1 can be reduced to another theory T2 if the dynamical laws of the former can be derived from those of the latter under certain conditions or restrictions. However, this model overlooks the fact that a scientific theory consists not only of dynamical laws, but also a phase space. And this phase space includes a variety of initial and boundary conditions. For this reason, the phase space contains crucial nomological information. For example, if a theory T1 is reduced to a theory T2, that means that the dynamical laws of the reduced theory can be translated to the dynamical laws of the reducing theory. However, if the phase space of the reducing theory is grounded in the phase space of the reduced theory, then the Nagelian reduction doesn't carry metaphysical consequences. In other words, the phase space structure of the putative reducing theory mustn't itself be grounded in the phase space structure of the laws of the reduced theory. Well, now I'm going to present the quantum theory of atoms in molecules. In this case, I am following Richard Vader, that is the main developer of QTAIM. Bien, in a series of papers, Vader poses this question: what physical property of a system reflects the elements of conceptual chemistry? Vader responds that this property is the action, and then he plants the idea that it is possible to define what is an atom in a molecule in terms of the least action principle and the Lagrangian method. Then Vader applies the Lagrangian method to quantum mechanics, and by minimizing the action, he obtains the Schrödinger equation and the energy functional for a quantum system in an stationary state. In the other side, Vader identified two different expressions to express the kinetic energy. One of these expressions is by Schrödinger, and the another one is associated to the Lagrangian method. And well, Vader said that the difference of this expression is locally proportional to the Laplacian of the electron density. And he establishes this equation. And when this equation is integrated over a region of space denoted by omega, and then he applies the Gauss theorem, he obtains this new equation in which this term is a surface term. Then here is interesting because if omega is the total system, then this term disappears and the kinetic energy is well defined. But if omega is bounded, then this term doesn't disappear, and then the kinetic energy is ill-defined. However, if omega is bounded by a zero flux surface, then this term disappears and the kinetic energy is well defined. The idea here is that it is necessary to work with systems that are bounded by zero flux surfaces in order to have the kinetic energy well defined. Bien, Bader also offers an observational or experimental basis for the concept of atominmolecule. And well, he says that in the case of a chemical system, particularly atoms and molecules, the dominant force is the nucleus electron force. And thanks to this fact, the morphology of the electron density is dominated by maxima. And this morphology reveals that the presence of a universal topological feature, that is the presence of zero flux surfaces. And this, the presence of these zero flux surfaces conducts to the exhaustive partitioning of the molecular space in mononuclear regions, omega. And well, according to Bader, these mononuclear regions, omega, are associated to the atoms in the molecule. Said in the author's words, what is perhaps remarkable is that the subspaces defined by the zero flux surface are immediately identifiable as atoms in a molecule, that is, as uniquely defined atomic fragments of a molecular system. Then, well, the assumption that the concept of topological atom corresponds to the concept of chemical atom relies on the additivity and transferability of the topological atom's properties, since these features are reasonably expected in chemical atoms. Well, now, Bader wants to define the quantum mechanics of an open system, of a system that is bounded by zero flux surfaces. In this case, he takes the energy functional of Schrödinger for a region of space denoted by omega, and the variation of this of this equation produces this new equation. And in this new equation, this term describes the variation in the surface of the omega of the subsystem. And the relevant fact of this equation is that this equation lacks of physical meaning, because lacks of physical meaning because the surface that is taken, because there is doesn't take into account any particular surface. Then, however, when this equation satisfies the Schrödinger equation, and then it is imposed the zero flux surface condition, then this equation acquires a physical meaning, and we obtain this new equation in which, this equation describes the flux in the variation of the quantum mechanical current density through a zero flux surface in the gradient vector field of the electron density. And the last step is to put this equation in an operational form. Then to put the equation in an operational form, Bader makes the substitution of the variation of the wave function by the action of a change generator on the wave function, and obtains the new equation. And the other step is to obtain the equation of motion for the generator G. G is the generator for a particular property, the property that is the importance for the study, no? And the last step is Bader take this equation and this one and equate it equal to, and obtain this equation that is the atomic statement of the principle of a stationary action for a stationary state. And this equation satisfies the Schrödinger equation in the postulates of the quantum mechanics. And according to Bader, this statement determines all the physics of an atom in a molecule. Summing up, well, Bader offers a quantum definition of an aim adopting the Lagrangian approach. The zero flux surface condition allows to define the kinetic energy of an open system, and this condition is chosen on the basis of experimental evidence. Well, the open subsystem defined by the zero flux surface comply with the transferability and additivity of chemical atoms. And the zero flux surface gives physical meaning to the equation that ultimately determines the mathematical structure of QTAIM. And well, at the final, it is obtained the atomic statement that determines any property of an atom in a molecule. Well, finally, well, thanks to this analysis, we can note that the Nagelian reduction model overlooks the important role that has the phase space in the construction of theories, particularly in the case of the quantum theory of atoms in molecules. And well, in this case, the zero flux surface plays a central role in determining the phase space of the reducing theory, i.e. the quantum mechanics. And the zero flux surface introduces information from the total system to define the subsystem. That is, the molecule defines the atoms that composes it. And the support of the zero flux surface resides in the experiment. That is, the experimental observations of chemical system lead to the imposition of the zero flux surface condition. Well, the zero flux surface as a boundary condition. And with this, meaning is given to the mathematical formalism that ultimately leads to the QTAIM. And well, to conclude, this very important function of the zero flux surface can be interpreted as a top-down metaphysical determination, that is, a determination from the molecular level to the level of quantum mechanics. And the zero flux surface is a mark of ontological distinction between these different levels of composition. Well, that's all, and thank you very much.
Gracias, Jesus. So does anyone have a question here in the room for Jesus? Jean-Pierre, yes.
It's okay? Okay. Thank you very much, Jesus, for this presentation. As you know, I have been working on this kind of question for many years. And in the last year, I have written two new papers which are about to be published. But may you resume the previous slide, for instance, because it is of paramount importance here. May you describe the experiment you are talking about precisely, please? What kind of experiments
actually
is it?
Yeah, no, there isn't a particular experiment. Bader also argues that the topological atoms comply with the transferability and the additivity properties that he said chemical atoms must have.
Or display.
Or display. Exactly.
But you know that Popelier, which is one of another key chemists in this field, qualifies this kind of statement, because transferability of an atoms or a group of atoms from one molecule to another is a purpose. Okay, yes. Is a purpose, is an object. Okay, and it is very difficult to obtain it. So the crucial point for your statement here is the basis of experiment, because in the current state of affairs, we have experiment related to the density, the electronic density, okay, And electronic density, in a way, is related to the zero flux surface. But if you want to assert any causal, retrocausal power, because philosophers here will ask you to develop a lot, you have to correlate or to make the current experiment on electronic density and the zero flux surface be more connected. Otherwise, you have no proof of experiment. And this is very, very discussed between chemists and sometimes between philosophers. Okay, so there is no experiment upon which you can rely. The only experiment we have is about electronic density. And as you know, the meaning of the electronic density is still on discussion. So I follow you in a way, but be careful to precise more the nature of the experiment. And I would like to work with you on this kind of question.
Yes, for sure.
Okay,
sure.
Thank you very much.
Yes, actually, you have reason. I agree with you because the transferability is not perfect. You can transfer an atom, a topological atom from one molecule to another molecule with only a few changes, but it's not perfect. But it's not perfect exactly. And actually, another criticism of the zero flux surface is that it's an ad hoc. You put by hand, or Bader put by hand. Bader tries to argue or he tries to argue that the zero flux surface has a observational basis, but no, it's not clear. It's not clear. I agree with you in that.
Merci. Thank you very much. This is a crucial point of your demonstration. So you have to go deeper. Okay?
Yeah.
And I can help you on this point. Okay?
Thank you.
Okay.
Thank you.
Olympia and then Klaus, okay? Olympia?
For instance, I would say that I'm very skeptical about
Downward
causation. However, I agree with your idea of top-down determination. How it is possible? Because I think that when people think in downward causation, is thinking in something different than determination, top-down determination. I mean, when Robin Henry is thinking in downward causation, I think many people, perhaps he doesn't, but many people think in causation like in Aristotelian words, efficient causation. And this is different. This is a determination. It's causation in Aristotelian terms, but it's not causation in the traditional
efficient causation.
Yes, traditional causation as understood since modern times. So I think that there is something there that you can explore a little bit more, because sometimes this kind of downward causation is interpreted in an efficient way, and not as you are talking about.
A semantic clarification.
Yes, a semantic clarification, as Jean-Pierre said. I think that this is important because I know that you are friendly with Aristotelian philosophy, new Aristotelian philosophy, and the idea of the determination of the whole under the parts. It's something that it is said also in quantum mechanics, independently of quantum chemistry. But this is not the same as downward causation as many philosophers think. This is only a suggestion to
yes, thank you very much.
Okay, thank you. And Klaus, maybe now we can hear you, maybe?
Hopefully, yes. Thank you, Jesus, and greetings to all friends. Maybe I missed something, but I don't understand why you call this hylomorphic approach, because Aristotle, as far as I read him, was a non or maybe anti-atomist. He was never talking about atoms. But how can you just refer to Aristotle here?
Well, if I understand your question, well, my approach is hylomorphic because I consider that the objects in general, but chemical system in particular, are composed of matter and form. The matter is a principle of individuation, and the form is understood in terms of the downward metaphysical determination. And in this case, the molecule defines the atoms that compose it. I mean, when an atom is isolated, is different when the atom is in the molecule, because the atom, when is part of the molecule, acquires properties that are in function of the molecule to which it is a part.
Okay, you are using those notions, atom and molecule, as if they are clear. That's for the first. I think the question Jean-Pierre put to you went in the same direction. I'm just thinking of hyle, the original Greek word, as denoting a substance, not matter, substance. And therefore, our other journal was called Hyle by Joachim Schummer. So therefore, I'm pretty sure that Aristotle never was talking about atoms and molecules. You are just using some very formal ways of looking at Aristotle, as far as I'm concerned.
Yeah, okay, but there is at least in contemporary analytic philosophy, there is an Aristotelian approach that is mereological, the wholes and parts, and I am adopting this approach. And in my case, chemical system or molecules are substances in the Aristotelian sense, and are molecular wholes that are composed of atomic parts. Why not?
Not in an Aristotelian way. Okay, you might be correct that some of the analytical philosophers are talking about that, but this is a conference on philosophy of chemistry, not on the philosophy of analytical things. I think it would be better to refer to substances, not to all those things we are so to say referring or getting from spectroscopy. You and some of the other people today were or are talking about the results of spectroscopy. You are interpreting this. You are not talking about the substances and their properties or dispositions, if you like. I was just wondering about why this is called hylomorphic, because for me it's not hylomorphic, it's just the opposite.
No, maybe I'm not understanding your question, because
maybe
I say that the molecule is a hylomorphic substance in the sense that it's composed of a formal part and a matter aspect. And
okay,
the formal, in this case,
you and all those quantum chemists are talking about atoms and molecules as if they are apples or nuts or something, real things. And this is not correct.
Okay.
Yeah, that's what I mean. You have to show how to get to those notions.
Yeah. Well,
we are not working with atoms and molecules in the laboratories.
Yes,
working with substances.
Actually, there is some approaches in which molecules are virtual parts of substances. chemical substances. Maybe it makes sense for you in that sense, because yeah, molecules in that approach are virtual parts, no substances like you say.
Okay, I'm sorry, maybe I'm just totally outdated in a way. So it's just my problem to look or to find Aristotle in that scheme.
No, it's okay.
But it's my problem. It's not your problem.
I get your question. I get your question. Thank you.
Thank you.
We are like 15 minutes already behind the schedule. I think we should go to the coffee break, and they come back because we are really late.
I would like only.
Yeah. We have time in the middle of.
We lost.
No, Klaus is not moving anywhere. Klaus is not moving. No, Klaus is not moving.
Klaus, hello. I don't know if you see me. Yeah.
Yeah.
I think that you are using the term substance in different ways. So you are thinking in substance and the meaning in chemistry, and substance for Aristotle is an individual thing. This is a substance.
Yeah,
so,
why not?
Yes, but I mean, the substance, I mean, the foam is a substance. I am a substance. I mean, an individual thing or anything is a substance when considered alone, and it's made by form and matter. And in this sense, only in this sense, in Aristotelian sense, this is hylomorphism. Only in this sense, not in the sense of substance in the chemical sense. In the chemical sense, substance is something different. It's something that reacts. It's something that has chemical properties. I mean, I think that hylomorphism in the context of neo-Aristotelian or Aristotelian philosophy, I mean, the term substance is very polysemic. So this is something that I think that you don't agree because you are using the term in different ways. I mean, you are saying something correct, but he's talking, Jesus is talking about another different sense, I think. So, well, we can continue to discuss this.
I'm not a specialist on Aristotle, but I read all these things about chemistry, so to say chemistry by Aristotle, and there's no sign of any atom or molecule or atoms in molecules. Yeah. So therefore, I was just wondering how those analytical philosophers can just put in this notion hylomorphic. Because for me, it's not matter, it's substance, and I think there's a difference between matter and substance. And if you are talking about matter, it's okay, but then we are talking about the philosophy of physics. You know what I mean?
Maybe you should change the author.
Can you give the microphone?
The notion of hylomorphism has been totally reconceptualized by Gilbert Simondon, a philosopher of technology, a French philosopher of technology, and I suggest you should read Gilbert Simondon because the concept of hylomorphism that developed can be of help for you because Claus is right. When you are talking about Aristotle, you are talking about matter. But if you want to include the notion of substance, you have to change the way hylomorphism is defined. And to do so, I suggest you should read Gilbert Simondon, who did this kind of work very efficiently. Okay, and we could discuss one about that. But Klaus is right.
Okay.
Be careful with that. But you have another kind of conceptualization of hylomorphism, which could be of help for you. And it was developed by Gilbert Simondon.
Okay.
Okay. Thank you.
Okay, thank you. Thank you. Thank you, Klaus, for your time. Really appreciate it. So now we have some time for coffee.